Hello, we are going to be doing section 7.3, day 1 today from module 7 notes. We are looking at angle and arc relationships in a circle, and today specifically we're looking at central angles and inscribed angles in circles. Now, central angles we've talked about before. A central angle is an angle whose vertex is in the center of the circle. I'm going to change one word here. Instead of in the center of the circle, I'm going to say at the center of the circle. And if we have a central angle, we know that the measure of that angle is exactly equal to the measure of that arc. So if we have this angle right over here, we know that the measure of angle C is exactly the same as the measure of arc AB. So if angle C is 35, then the measure of arc AB is also 35. For central angles, those are the easiest ones. The measure of the angle is exactly the same as the measure of the arc. An inscribed angle. Inscribed angle is an angle whose vertex is on the circle. So see, this angle vertex is on the circle, not at the center, but on the circle. Same thing over here. So an inscribed angle is an angle whose vertex is on the circle. Vertex is on the circle. When this happens, then the measure of the angle is 1/2 of the measure of the arc. So in this case down here, angle 1, the measure of angle 1 is 1/2 of the measure of arc AB. And likewise over here, this one is a tangent and a secant, so we have this whole angle right here, angle ABC, or just angle B, is equal to 1/2 of the arc it intercepts. And this one's a little bit harder to see down here. It's this arc right there. 1/2 the measure of arc AB. Let me go back and color this arc over here. So that angle is 1/2 of that arc. All right, let's take a look at a few problems here with this information. We have some examples. The measure of arc MK is 48. So this arc right here, MK, is 48. And we want to find the measure of the angle. Well, the angle is 1/2 of the arc. The angle is 1/2 of the arc, so measure of angle L is 1/2 of that 48, or just 24. When we look at this next one, the measure of arc CO is 150 degrees. So this arc out here is 150 degrees, and we want to find the measure of angle COE. And angle COE is this inscribed angle right here, that big angle. Well, in order to find that big angle, we're going to need all of this arc out here, this big major arc out here. To find that, we know that there are 360 degrees in an entire circle. So we can do 360 minus the 150, which is 210. That means this big arc out here, all of that is 210 degrees. Now the angle is 1/2 of that big arc, So the measure of angle COE, a half of 210 is 105. When we look at this next one, down here, a couple of things right off the bat. I see a diameter right here. That's important because then we're going to see 180 degrees somewhere, because 180 halfway around the circle. All right, arc JI is 50 degrees, so I'm going to put that in over here. JI is 50 degrees. Segment JU is parallel to segment IE. These guys are parallel. And we want to find arc JU. Oh boy. This up here is what we're looking for. All right, a couple of things going on. Let's see. Angle U is an inscribed angle for this arc. See, if you follow the sides out, it hits this 50-degree arc, which means the angle in here is half of that arc. So that's 25. Now we have parallel lines and alternate interior angles. That means this angle down here is also 25. Those parallel lines with a transversal, alternate interior angles are congruent. Now we can take inscribed angle I. If the angle is 25, then the arc must have been 50. Oh, cool. Now the top half of the circle is 180 degrees. There's 50 here and 50 here, which makes 100 together. That leaves 80 for arc JU. So measure of arc JU is 80 degrees. Okay. Again, like what we were doing earlier, a lot of the work is actually done in the diagram. So be very careful with what you're writing and make sure you write down stuff in the diagram. That's where the work is. That's important. Okay, going on to the next page. There are some more properties with inscribed angles. And it says if two inscribed angles, remember that's vertex on the circle, intersect the same arc or congruent arcs, then they are congruent. So let's look at this angle C and this angle S. See how angle C, the sides intercept arc or create arc LK? Angle S, if I follow those sides out, it also intercepts exactly the same arc. So angle C and angle S, both angles intercept the same arc, so those angles are then congruent. Angle C is congruent to angle S. Okay? Looking at the other case over here, where if I tell you that arc TM is congruent to arc XE, so if arc TM is congruent to arc XE, so then this inscribed angle I creates or intercepts arc TM. This angle E intercepts or creates arc EX or arc XE, then those two angles are congruent. Then angle I is congruent to angle E. All right. Looking at this next one, if an angle is inscribed in a semicircle, then it is a right angle. All right, so let's, we have a semicircle, so we need a diameter here. I'm going to go ahead and put that diameter in. Now we're going to have an angle that's inscribed in that semicircle. That means that one inscribed vertex is on the circle. And inscribed in that semicircle means that the angle has to hit both ends of the diameter. So we're looking at this. And here's what this says. Inscribed angle, vertex on the circle, the sides hit the ends of a diameter. So we have a semicircle. All right, down here, this is a semicircle. That's 180 degrees. Inscribed angle, then, is going to be half of that arc. If that arc is 180 degrees, then this angle up here has to be 90 degrees. And that tells us that we have a right angle. Okay. Last one, and then we're going to do some problems on these three properties. If a quadrilateral is inscribed in a circle, then opposite angles are supplementary. All right, let's put a quadrilateral inside here. Now, for a quadrilateral to be inscribed in a circle, it means all four vertices have to touch the circle. So here I've drawn a quadrilateral. It doesn't have to be a rectangle, it doesn't have to be a square, it doesn't have to be a rhombus, it doesn't have to be anything in particular. It just has to have all four vertices on the circle. Let's call this Q, U, A, D. All right, so if this quadrilateral is inscribed in a circle, then opposite angles are supplementary. Supplementary, remember, means add to 180 degrees. So opposite angles, angles that are straight across the quadrilateral from each other, not adjacent or consecutive, not next to each other, but rather opposite. So angle Q and angle A are supplementary. They add to 180 degrees. Also, angle U and angle D. Okay, so opposite angles add up to 180 degrees. All right. Let's go ahead and do some problems here with these last three properties. All right, given that the radius of circle D is 9 and the measure of arc AL is 60 degrees, I would like you to find the perimeter of triangle AEL. All right, let's put the information in that we know in this diagram. So the radius of circle D is 9. Okay, so there's two radii on here. Each one is 9. So that one's 9 and that one's 9. The measure of arc AL is 60 degrees. So let's put a 60 degrees up here. All right, now let's figure out. We have to find the perimeter of this triangle. That means I need to know all the side lengths. Well, clearly this is 18 right here, but that's the only thing I know. We do have this inscribed angle, angle E, right here. Inscribed angle, so the angle is half of the arc. The arc is 60 degrees, so that means this is 30 down here. And let's look at angle L. Angle L is inscribed in a semicircle because its sides hit the ends of a diameter. So if you want to think about it this way, it's 180 degrees out here, which means this angle L is 90 degrees. Oh, and when we look at that, we have a 30, 60, 90 right triangle. And you know those properties. Let's see, to find the side lengths. The hypotenuse is 18. So to get from the hypotenuse back to the short leg, hypotenuse to the short leg, we're going to have to divide by 2, which makes this piece up here 9. And then from the short leg to the long leg, we will multiply by the square root of 3. So that makes this long leg, 9 square root 3. The perimeter then of triangle AEL, if we add up the 3 sides, the hypotenuse was 18, plus the short leg, 9, plus the long leg, 9 square root 3. We can only add these two together, 18 and 9, that's 27, and 9 square root 3. We cannot add the 9 and the 27 because that 9 is being multiplied by the square root of 3. That's the answer right there, 27 plus 9 square root 3. Okay? All right, now let's look at this one over here. Let's see, we have to find A, B, C, D, and E. Oh boy. All right, a lot of times when you have to find a lot, I like to list them over on the side. And then it doesn't matter what order you find them in, you just have to find all of them. And again, I list them over here just to make sure I find everything. All right, let's start off. Let's see, right away I see, oh, we have a quadrilateral inscribed in a circle. That means opposite angles are supplementary. So if angle H up here is 110, then B down here, these two have to add up to be 180. So B has to be 70 then. Okay. And then, oh, you know what? I'm going to do that also right in here. If angle O is 86, it has to be supplementary with this A, so these guys have to add up to be 180. If you do 180 minus 86, 180 minus 80 is 100 minus 6, 94. So A is 94. Okay. Now, to find the arcs, it becomes a little bit trickier. Let's start off finding this C here. And what I'm going to do is I'm going to start at this angle O. And this angle O is an inscribed angle, and if I follow the sides out from angle O, then its arc is all of this. And we know that that angle is half the arc, so that arc has to be 2 times 86. 2 times 80 is 160, 2 times 6 is 12, so 160 plus 12, 172. So all of this green arc here is 172. But look, this much is 89. That much is 89. So if we do 172 minus 89, that one I can't do in my head. 12 minus 9 is 3, 16 minus 8, 8. So that leaves this C part here as, I'm going to put that in a different color, 83. That's just this arc C, or arc EM. C is 83. Okay, now let's see if we can find another one. Oh, what if we do this down here, this angle M, that inscribed angle, if I follow those sides out, that's going to hit all of this arc. I'm using lots of colors in here so you can see what I'm talking about. Angle M, follow the sides out, that's going to hit this arc. Oh, look at that, and it overlaps that 89 again. All right, angle M was 70. So then this big arc, this orange arc up here, that's got to be 140. Now if we do 140 minus off that 89, minus 8, 5. That means that this E in here, that's 51. Okie doke. All right, now to find D, I'm going to do this a little bit differently. I'm not going to use any angles anymore. We know that the a whole circle adds up to be 360. So if I add up all of the pieces, so if I add up this 51 plus this 89 plus this 83, let's see, 10, 13, 16, and 6 is 22. That adds up to be 223. And now if we do 360 in the whole circle minus these 3 of 223, 7, 3, 1, 137. So D is 137. Yes, you may use a calculator for this addition and subtraction. I just don't have one close by, and it's faster for me to do the addition and subtraction than it would be for me to go hunt down a calculator right now. All right, let's look at number 6 down here. Again, we have to find A, B, C, D. Same thing. I like to make a list down here, make sure I can find everything. A, B, C, D. And we start looking. Oh, well, look at this angle D. That's a central angle, vertex at the center. Remember, vertex at the center is exactly the same as the arc, so D is 57. Nice. All right. Let's see. Let's start at angle, let's see, let's look at angle C. So C, that's vertex on the circle, and if I follow the sides out, from angle C, follow the sides out, it hits this arc of 79. And we know inscribed angle, that angle is half of the arc, so we need half of 79. If you can't do that in your head, grab a calculator. 79 divided by 2, it is 39.5. The next one I see is angle A, another inscribed angle. Let me follow the sides out. For angle A, that goes to the 57. So for angle A, we'll need half of that 57. And half of 57 is 28.5. That's angle A. That's this one in here, not the central angle down here. All right, last one, B. B is this angle right here between this chord and this tangent. It is an inscribed angle, and for angle B, we need to know this arc. Well, to find that arc, we have a diameter right here. So there's 180 degrees. And if we do 180 minus 57, let's see, I'm going to do 180 minus 50, which is 130, and then I'm going to subtract 7 more, so 123. That arc then is 123. To find angle B then, we'll need half of that 123, which is 61.5. Oops. And you know what? All of these are degree values. Sorry. I won't mark it wrong if you do not put the degree symbol on there, but I just want to be exact for your notes. Okay. Number 7. Again, find A, B, C, D, and E. Oh boy, let's list them down here. A, B, C, D, E. Oops, I don't know if that's off the screen for you or not. Oh, there we go. Okay, I can adjust it. Oh my goodness. What do you see? Oh, well, I see a central angle right here. This is 88 degrees. So the arc for that central angle also has to be 88 degrees. So B is 88. That means then angle A, which is an inscribed angle, it has to be half of that 88, which is 44. Oh, angle D, that's an inscribed angle. That inscribed angle then for angle D, here's the arc for angle D, which is 150, so we need half of that 150. That's 75. All right, and the last two. Let's find arc E first. So we know there's 360 degrees in the whole circle, so we can add up the 150 and the 88. 238. And then if we do 360 minus that 238, 10 minus 8 is 2, 5 minus 3 is 2, 3 minus 2 is 1. So this arc E is 122. Okay, and now angle C, inscribed angle, so it's half of that arc, which is 61. Oh, and I think I forgot all the degree symbols again on here. I'm so sorry. Again, I won't mark off for that if you do not write it on a test or a quiz or on your homework. I just want my notes to be accurate. All right, we have one more problem to go. Can you make it? I know you can. I know you can, so stop it. Stop whining. I know you can make it. We're almost done. Oh boy. So given arc AB is 10 degrees, arc BC is 20 degrees, and arc ED is 20 degrees. Find all of these guys. Oh my goodness. All right, well, let's label this diagram with what we know. Arc AB is 10. Arc BC is 20. Arc ED is 20. Okay. Let's see what we can find. Well, let's see. For sure, I see that angle E down here, angle BEC, that one's an inscribed angle, so that has to be half of this arc. So that has to be 10. Okay, so where is that arc B or angle BEC? Angle BEC. Oh, that's 10. Okay. The other thing I like to look for is a diameter. Diameter. Do we have a diameter anywhere? Oh yeah, we do, right there. Angle or segment BE is a diameter. So if you look at the top half here, that has to be 180 degrees. Which means then that if that's 20 and that's 20, that makes up 40. So that leaves this arc CD as 140. Is that one of the things I have to find? Oh yeah, right here. That's 140. Okay, let's look at the other side with the diameter. Here's the diameter. That has to be 180 degrees. If that much of it's 10, then this part down here has to be, 170. Okay, so that's arc AE, 170. All right, now once you found all the arcs, then we can kind of just go through and find each individual angle. Let's look at angle C. C is an inscribed angle. If you follow the sides out, it hits the end of that diameter. Follow the sides of angle C out so it hits the ends of the diameter, which means angle C is a 90-degree angle. All right. Angle D, here's angle D. It's an inscribed angle, vertex on. Let's follow the sides out. When you follow the sides out, angle D doesn't hit the ends of the diameter. It actually hits the ends of this 170-degree arc. So we'll need half of 170, which is 85. Oops, sorry about that. Mess. Oh, and it's too wet right now. I can't white over it, I don't think. Angle D, 85. Oh, this pen's leaking. I think I need to throw it away. Let's see, angle BAD. Angle BAD. 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 That can't be right. Oh, yeah, it can. BAD. I'm sorry. It's not drawn in here, but we can do it. Let me find another pen. BAD. If I draw it in there, it's an inscribed angle, and sides hit right here at B and would also hit here at D. So its intercepted arc would be 20 and 140 together, which would be 160. And then we have an inscribed angle, so we'll need half of that 160, which is 80. And one last one, angle BED. BED. Oh, again, that one hits exactly the same arc, hits exactly that 160 degrees, so that is 80 degrees. Oh, I think I got off. There we go. All right. Thanks very much for staying so long. I know it was a long lesson today. Hopefully it makes sense. If not, please join me at a Zoom meeting sometime, and we'll try and straighten it out for you. Thank you.